Alright, this is our fourth quarter ISP poster titled Acids and Eggs. It just kind of flows from left to right with each part of our lab. Our data is in the middle with all the pictures of our results. Over here we have our analysis, conclusions and limitations, and resources down at the bottom. Over here are just some pictures of the acids that we used. Okay, so for our experiment, we wanted to test how acids reacted with calcium carbonate in eggshells. So we just went out and bought items that we researched online that had acid in them. So we came up with vinegar, orange juice, vitamin C, aspirin, and Coca-Cola. So we put them in a cup with 500 milliliters of whatever substance they were in, and then we would wait and see how the egg reacted with the outside of the shell. And sometimes there's with vinegar there's different measurements of time, because it went so much more quicker than the other ones, or while the rest of them are just in days. And we had to replace some of the substances after they stopped reacting, like orange juice or the Coca-Cola, because there wasn't enough of the acid in there to keep on reacting. So they were replaced regularly.
Alright, our problem was how do eggshells react with different kinds of acids. Now, the eggshell, which is almost completely made of calcium carbonate, reacts with each acid differently. And in our background, we talk about how different acids, some fun facts about those, and the formulas for each, and describe different parts of the egg, even though the shell is really the only part that reacts with the acid.
Our hypothesis was, if eggs are placed in different acids, then you can see how the eggshell reacts differently with the different acids. Our materials were, as I said earlier, vinegar, orange juice, vitamin C, aspirin, and Coca-Cola. We also used a clock to time the amount of days, and of course 5 eggs to do the experiment with.
Alright, now our procedure involved pouring 500 milliliters of each substance in each glass, and then you place the egg inside. And then for each time we did a different acid, we had to use the different times for some of them. But each time all you do is put the liquid in, the acid in, and then you drop the egg in, and then you start the timer or watch your clock.
So we already kind of talked about how this part of our data is set up, but right here is our eggshell qualitative observations during the disintegration of the eggshells, and we just put those kind of down here in this table. This is the last part of our data. It just shows the reactions that worked and how just the balanced chemical equations for those reactions. So our analysis, it basically talks about how the reactions differ from each other. It talks about some of the similarities, and we got it talks about how the concentration of the acid kind of had the biggest effect on how quick it dissolved, and actually two of our acids didn't react really at all, so that was in our analysis as well.
Alright, in conclusion, our hypothesis was correct. We said if eggs are placed in different acids, then you can see how the eggshell reacts differently with the different acids. Now, in some of our reactions, or some of our acid reactions, the eggshell did not completely decay, but it did change, like the Coca-Cola brown and the vitamin C supplement orange. It changed to orange. And then, along with the orange juice, it started to decay until we took it out and it cracked.
For limitations, our biggest limitation was probably the fact that we had to take the egg out. You'll notice the spoon there. Each time to observe it in the orange juice and the Coca-Cola, because you couldn't actually see what was going on. So yeah, that was a thing that we had to do, and it affected maybe it could cause the eggs to break, because those were the only 2 eggs that actually ended up breaking. And we said basically the best improvement would probably be to hard boil the eggs next time, because we don't think that would have an effect on the strength of the shell, and it wouldn't prevent us from having to stop the experiment.